Hi, and welcome to this section of the tutor where we're going to kind of expand on what we learned about in percents, and we're going to talk about something related, and that is the topic of ratio and proportion. Percent, if you remember, is just comparing a number to 100, so we have to write that fraction that way. Now we're going to kind of broaden that a little bit. We're going to talk about the bigger picture, and that's the topic of ratios, okay? Let's say you have two pens and 5 pencils. So in your hand here you have 2 pens, your hand here you have 5 pencils. So the question is, what is the ratio, and I'll tell you what that means in a minute, of pens to pencils, okay? So let's figure that out, okay? You have 2 pens and 5 pencils, okay? In your hands here, okay? What is the ratio of pens to pencils? Well, the way you write this down, and I know you don't quite understand this just yet, we'll get there. You say you have 2 colon 5, okay? What this means is this is the number of pens, and this is the number of pencils. So it's really nothing special. You just put the symbol in the middle, it's a colon, okay? And then basically all it means is this many pens corresponding to this many pencils, okay? That's all it means, okay? Now you can also write it as a fraction, and that's really the much more common way to do it, okay? You can write it as a fraction. Because you have 2 numbers here, you could have a 2 on the top and a 5 on the bottom. And this number is the pens, and this number corresponds to the pencils. What it means, okay, what it means is that for every 5 pencils, okay, that I find in a drawer, let's say, I think that I should find 2 pens, okay? That's what a ratio means, okay? For every 5 pencils, I should find 2 pens, okay? If I were to pull 10 pencils out of the drawer, okay, 10, not 5, but 10, so I would double this, okay? How many pens do you think you would find? Well, if I pull 5 pencils out and I expect to find 2 pens, then if I pull 10 pencils out, 10, then I think I probably should find 4 pens, okay? Because I'm doubling everything. I pull twice as many pencils out, so 10 pencils, okay? I should find twice as many pens. So what this is telling you here, this ratio is what we call it, is it's kind of telling you how many of something you have compared to how many of something else, okay? In this case, it's pens and pencils, okay? So any fraction that we've written up till now, remember we were multiplying, dividing, adding, subtracting fractions and all that. Any fraction is really a ratio. It's a top number compared to a bottom number. In this case, we're putting labels on it, pens and pencils. It could be cars and trucks. It could be apples and oranges. It could be any 2 things you're comparing, okay, when you have a big bucket of them, okay, and you want to find out how many oranges, if I pull 10 oranges out, how many apples do I expect to get out, that kind of thing. And so this is exactly what a ratio is. Now let's pick another ratio, okay, let's kind of get a couple more examples. Let's say you have, in a room, you'll say you have 2 women, okay, and 10 men. 2 women and 10 men, okay? What is the ratio of women to men? The ratio of women to men. Well, it's 2 women to 10 men. Just write it like this. 2 colon 10, okay? That means that there's 2 women for every 10 men, okay? For every 10 men, okay? Now you can also write this, as we said before, as a fraction. You can put the 2 and the 10 like this. So 2 women for every 10 men. Now, don't forget that this is a fraction, and you know you can simplify fractions, okay? And this is a ratio, but it's really kind of like a fraction. I mean, it is a fraction. You're just writing it with this funny symbol here instead of this funny symbol here, okay? But it's got the same numbers, okay? So you can simplify ratios like this and like this, just like you simplify fractions. That's the good news, okay? So if we were going to simplify this fraction, forgetting about the fact that it's just a ratio, how would we do it? We divide the top by 2 and we divide the bottom by 2, right? We've been doing that over and over and over again. So the top would be 2 divided by 2 is 1, and the bottom would be 10 divided by 2 is 5, okay? And you can do the same thing here. You could do the same thing here, and if you were to do that, you would find that this ratio comes out to 1 colon 5, okay? You can do the same simplification here. 2 divided by 2 is 1, 10 divided by 2 is 5. Now in your books, when they give you something like there's 2 women and 10 men, what's the ratio? They're going to want to know the simplified ratio after you fully simplify everything and get it as simple as you can. What this means is that you had 2 women and 10 men. That is the ratio, 2 to 10. Okay? So for every 10 women, okay, for every 10 men, excuse me, that you have in a room, if you pull 10 people out, I expect to get 2 women, okay? But that is exactly the same thing as pulling 5 men out and expecting to get 1 woman. Okay, that's exactly the same thing. It's a proportion there. It's a ratio. It's proportional there, okay? Because if I take 5 women out, 5 men out, okay, then I expect to get 1 woman. Okay? If I do that over and over and over again, and I do that, let's say, 2 times, then I would pull 10 men out. Well, then I would expect to get 2 women back. And then if I were to pull out, let's say 3 times 3, I can multiply this times 3. Let's say I would pull out 15 men out. And so that's multiplying this bottom number by 3. So I would pull out 15, 5 times 3 is 15 men out. Then I would expect to get 3 women back. Because this is the basic ratio right here. So everything's in terms of a fraction, okay? It's just expressing one thing compared to another, kind of like the percents, okay? Now we're going to do some problems to kind of show you why this is useful, okay? Because that's really the most important thing here, okay? Why is this useful? Let's say you have a bucket of apples in the grocery store, okay? You have 2 good apples picked for every 12 that you pull out of the bucket. So you pull 12 apples out of the bucket, and only 2 of them are good. Okay? So you have a bucket of apples, okay? For every 12 apples picked, okay, only 2 are good. So that's not very good. That's a pretty ugly bucket of apples. 12 apples you pick out, only 2 of them are good. The rest of them are rotten, okay? So you have a ratio here. You have a ratio here. You pick 12 apples, only 2 of them are good. The ratio is going to be 2 good apples for every 12 bad apples, okay? You can also write it as 2 over 12, okay? Now, we can simplify these ratios just like we always can, okay? We can divide the top by 2 and the bottom by 2. Okay, just like any fraction, nothing special. 2 divided by 2 gives you 1. 12 divided by 2 gives you 6. Okay? And so because this is the simplified version here, you can do the same thing over here. So this can be 1 colon 6. Just the same thing. 2 divided by 2 is 1. 12 divided by 2 is 6. So I was given some information. I was able to write a ratio of good to bad down. And so this is the basic thing. For every 6 apples I pull out, 1 of them should be good. And that is exactly the same thing as what I knew here. I just reduced the information that I knew, okay? Now, why is this useful, okay? Let's say your mother comes home and tells you that the ratio of good to bad apples is only 1 to 6. Then if I go back into the store and pick 30 apples at random, 30 apples I pick out of the bucket, how many apples will be good? So now I have a ratio, 1 to 6, good apples to bad. And then I go back to the store and I pick 30 apples and I take them home. How many good apples do I expect to have? Well, it's not that hard. You take the 30 apples that you're picking and you just multiply by your ratio, which is 1 good apple to 6 bad apples. Okay? So to do this, I'm going to make it 30 over 1, okay, which is going to equal 30 times 1/6. Okay? 30 times 1 gives me 30. 6 times 1 gives me 6. And then to simplify this, 30 divided by 6 is simply 5. So I should get 5 good apples out of 30. This is why ratios are useful. Somebody can go and do all the work for you and tell you the ratio of good to bad apples is 1 to 6. And then I could tell you, well, if I pick 30 apples, I'm only going to expect to get 5 good ones. And this makes sense because somebody goes out and does the work for you. 1 out of every 6 apples picked are good, okay? Here, 5 out of every 30 apples picked as good. So it's the same ratio, okay? It's the same ratio. So I could go and pick any number of apples. I could pick 250 apples, and I could predict how many apples I would have good. And the only thing that I need to be able to do that is I need to know the ratio of good to bad apples, okay? Good to bad apples. This is why ratios are good. This is why ratios are useful, okay? I'm going to do one more quick problem, kind of like a word problem. And that's going to be the following. You have a class of students. There's 20 students in the class. 2 out of 5 students have A's. And the question is, how many students have A's? Okay? So you have 20 students. Okay? 20 students. And you know that 2 out of 5 have A's. Question is, how many students have A's? That's what I'm trying to figure out. You know that 2 out of 5 have A's, but how many students have A's total? Okay? Well, you have a ratio here. Okay? You have a ratio. 2:5. But really, it's much more useful to write it as 2 over 5. You're almost always going to be dealing with the fraction. Okay? Sometimes you'll see them ask you to write it down like this, but this is really the much more useful way to write it down. Okay? So in order to find out the total number of students, you just take the total number of students, multiply by your ratio, which is 2/5. Okay? Now I'm going to make this 20 over 1 in order to multiply fractions, just like before. Okay? 20 times 2 is 40, and 1 times 5 is 5. Okay? Now to simplify this, 40 divided by 5, using multiplication tables, is 8. So 8 students have A's. Okay? So that kind of makes sense. Okay? 2 out of 5 people have A's. 20 total students in the class, 8 of them have A's. Okay? 8 of them have A's. And that's kind of how you do it. You define a ratio, which is what they're giving you here. Anytime you see something out of something, that's a ratio. It's a dead giveaway for a ratio. So when you're dealing with problems and ratios, look for the information in the problem that's going to give you the ratio. In this case, I gave you 2 out of 5, so I wrote my ratio. Simplify the ratio if you can. In this case, you can't simplify it anymore, so we just stuck with it. And then if they're asking you to find the total number of students or something like this, you're just going to end up needing to multiply by that ratio. And multiplication is the way in which you use this ratio and you chop down that initial number to get what you're after. And that is an introduction to ratios and how to use them.